The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is David Simpson. Thanks for joining us today for this short webinar. Got some information on the screen for you. People almost always ask where they can get the slides and other materials for the webinar. I've got a couple of places actually. The one on the bottom first, if you go to our company's website, themisync.com/webinars, you will see this webinar listed close to the top, and there will be a link for you to get the slides there. In the next day or so, you'll get a replay also posted of this so that you can share it with your friends who weren't able to attend. We also have put up a special link for this webinar, themisync.com/REXX. There you'll also see a link to the slides from this presentation, as well as a link to download a bunch of the samples that I'm going to talk about in the presentation. So you've got some great links to resources. On the webinars page, we also have replays and links to both past and upcoming webinars. One of my colleagues, Gerhard Adam, a few months ago did a REXX webinar on the parse command. So you got some more REXX stuff as well as just webinars on a bunch of different development and admin kind of topics on all kinds of stuff. Up front here, I should give some credit to the guy who really put together most of this presentation. His name is Rich Fazio. I actually see some of my former colleagues that worked with me and Rich years ago when this thing was put together. This presentation was delivered this year at IDUG North America, and it was based on a presentation that Rich Fazio did in 2005 actually at IDUG, and I noticed that there hadn't been too many people talking about the REXX DB2 interface lately, at least at the groups that I've attended, and not a whole lot has actually changed in that amount of time. So I asked Rich if I could have permission to update his presentation and inserted a little bit of my own stuff in there. He was cool with that. So that's what this came out of, and you'll notice that I was too lazy to take the slides off of the IDUG template. So you're getting a slightly reworked version of what I delivered this year in Anaheim at IDUG North America. And again, full credit to Rich Fazio for the original genesis of a lot of this material. I think REXX is a neat little tool that we have on the mainframe for, I'll call it quick and dirty scripting things. You can use it for a lot more than that. But we used it at one shop that I used to work at to kind of fill some gaps that, for some functionality we needed that wasn't provided in any of the tools that we owned. Or maybe it was provided in some of the tools that we owned, but we didn't like the interface or whatever. You'll see a couple of examples of that coming up. So I'm going to go, about probably the first half of the presentation will be looking at some of the mechanics of REXX and the DB2 interface and how we embed SQL in REXX. And then the rest of it will be just looking at some examples of what I've used that for. And again, some of those samples come from Rich. A lot of them come from Rich. Some of them are ones that I have invented since then. And I think most of the samples that are in the presentation are also in the zip file that you can download from that first link that you see on your screen right now. So themisync.com/REXX. the webinars. Either one of these links has a link to download the slides from the presentation. And the webinars page obviously has more than just this presentation, but also other past webinars that we've done, in addition to one or two that we have coming up. So that is the agenda. Let's go ahead and dig in. Again, I should. My name is David Simpson. I work for Themis. We do training consulting on a variety of topics. The thing I specialize in is mostly DB2. So I teach classes on various DB2 topics, from application development through database administration and such. All right, so we're going to take a little bit of what REXX is, and what is its place on the mainframe. Different clients that I go to have different opinions about what REXX's place should be in their mainframe environment. Is it just for personal use? Can we put it in production? There's a lot of different opinions about that. So I'm not going to really render an opinion here so much as show you, what I've used it for. It's a scripting language, right? It's a language that is pretty easy to write in, pretty easy to read, pretty easy to develop quickly, and we'll talk about that in just a second. We'll take a harder look at the REXX DB2 interface. So how do I use this scripting language to embed SQL or use it to run SQL statements, attach to DB2, connect to DB2, and get results. We'll talk a little bit about error handling. So, when I get a negative SQL code back from DB2, what should I be doing with that? I'll show you some sample code that we have, and you'll actually see that in a lot of the samples that if you choose to download those as well. And then we'll talk a little bit about some sample uses or some things that I've used it for. All right. So, what is REXX? Well, I actually went to Wikipedia, and you'll see that in a minute. But it's a scripting language that's supplied with ZOS. So if you have a mainframe, it's there. It does run other places as well, but largely I've seen it used up on the mainframe. We can run it interactively using TSO or in batch. A couple of different ways to invoke it in batch. One of them is to use TSO. We can use it to create scripts, right? So you got a little task that you want to automate, something that you do every day, a query or a series of queries that you need to run every day if part of a health check or something else. It's pretty easy to embed those inside of a REXX exec and run it either interactively or in batch. We've had direct DB2 interface since about DB2 version 5, so that's getting to be a while ago now, and not a ton has changed with that interface since then, with the exception of, I think it was in version 8 or so, they improved the performance of it quite a bit. It got something like 10 times faster, somewhere in there, to run a the overhead anyway of running a statement. So it's pretty easy to do. It's pretty efficient now. In terms of should we be writing production kind of programs in REXX? Again, various opinions about that. If you're a developer, you probably want to talk to the DBAs in your shop or whoever's in charge of standards, before you plan on putting this into production. But what I use it for as much as anything is things for my own use or for the use of my team, just to do things that my tools don't do too well. Okay, or things that are custom that my tool vendor would never think to do because it's just for me. Right. So as I said, I went to Wikipedia. This is what it says, right? Wikipedia, the gold standard for figuring out what things are. Again, it's a scripting language. Right. It fills a hole in the DB2 space because if you go out and look at other databases, things like Oracle or SQL Server, those databases actually kind of come with a proprietary scripting language that you can use to do things very similar to what we're going to talk about. DB2 of late does have SQLPL, which is a procedural SQL language, but we're a little bit limited with that to things like stored procedures or user-defined functions on DB2's OS. So REXX can actually kind of fill that void, for little things that I want to script, that involve more than one SQL statement or some procedural code that needs to surround the SQL. And when I need to go to DB2, I can do it. And so that is what I've used it for over the course of my career. So bad things and good things. Well, it's interpreted code, right? So it's going to be slower than the equivalent COBOL or C or assembler or pretty much any other compiled language that you might write. It is dynamic SQL. Right, so there's no static SQL embedded inside REXX unless you call a stored procedure, which you can do with REXX, but then that is eliminating some of the benefits of simplicity that we've been talking about. And because it's dynamic SQL, I can't do what we'll refer to like in COBOL as a singleton or embedded select. In COBOL you've got this nice feature where if you're only going to get one row back, you can do kind of a quick and dirty with cursorless select, right, an embedded or singleton select. No such thing in REXX, so even if you're going to go grab one row, you are going to need to do it via a cursor, and we'll see exactly how to do that in just a second. The good things, well, it's free, right? It comes with your mainframe and with DB2, the REXX DB2 interface. If your system people have run through all of the steps in the install of DB2, they have installed the REXX interface. It is one of the jobs, or it's in one of the jobs that they run to install DB2. So it should be there on most DB2 subsystems already. REXX is really laissez-faire about variables. Right, so you don't have to have, you're not going to develop a very structured working storage section like you do in COBOL. It kind of allocates variables as you use them, and so I don't even really have to define them at all. It defines them as needed, and we'll see how that works in a second as well. It pretty much supports just about anything you can do with an SQL statement. Right. Okay, because it's interpreted, we said that was in the disadvantages list. Well, the advantage there is that I can iteratively, develop and test something very quickly. If it's an interactive, TSO-based REXX, you can literally, type save and run it from the command line instantly. You don't have to compile it. There's no jobs to run. It just you save and test. So the development process can be pretty quick. The testing process can be pretty quick. It's pretty easy to try out and use very quickly. Okay. All right. So let's take a little bit of a look at the coding, and then we'll look at some uses. So here's a sample. A sample Rich Fazio REXX, and those of you who know Rich will probably recognize this. So you can think of that label, right? Select porridge routine. You can think of that kind of like a paragraph. It's a labeled statement, group of code. If you're a COBOL person, it's kind of like a paragraph. All right, so at the top we're calling it. That's kind of like a perform, and so we're going to do all the stuff in that chunk of code and then come back. So I'm setting the eat porridge flag to a no. Notice I didn't have to define that variable anywhere. Right? So eat porridge flag is now kind of a character or a string, and it's a string because when I used it first, I put letters in it. And so I don't have to define variables. It just it defines them on the fly as I use them. All right, and I'm going to do a do until eat porridge flag as a yes. I'm calling some other routine not seen here called taste, and if the taste is bigger than 5, I keep going. If it's less than 5, I keep going. If it's equal to 5, then I set the eat porridge flag to a yes. All right, so you see a lot of the constructs of a programming language here, right? We've got conditions, we've got calls to other routines, we've got a loop going on, and so on. Okay, so it's fairly simple, straightforward little language. If you've written in any other programming language, this is not going to be a stretch. Pretty easy to use. Okay, and you see the flow chart for what we just talked about there. Comments, in terms of comments, the way you put comments into REXX code, it's going to use the C or Java convention there. Anything between those two delimiters, slash, asterisk, and asterisk slash, is a comment, can span multiple lines. Conventionally, you'll see comments just be all on one line, but it doesn't really matter where you put them. Just everything in between the two delimiters is comment. So what you see down here in my taste routine, where I'm checking, greater than 5, less than 5, and a little comment off to the right, that's actually fairly common. Just let me know what this line of code is doing. If you can do that in just a couple of words, you can stick it off to the right in comments, and that's actually fairly common. You see that in REXX. As always, comments are good, right? Comment the code. Leave something for the person who follows you to read and know what you were doing. Okay. Another thing that is an interesting construct in REXX is the concept of the stack, the data stack. You see this used a lot with files. If I'm going to read and write to files, one of the ways to do that is to either retrieve or write out the file from the stack. We're going to use it when we start issuing DB2 commands. So if you want to do like a display utility or a start or stop object, you can do that, and one of the ways we're going to do that is by sticking the commands we want to run onto the stack and then submitting them up through the DSN command interface up to DB2. As a practical matter, almost always the only way I use the stack is the first way. If you queue something onto the stack, it's just going to add basically a record. You can think about it, it's an area of memory, but you can think about it like a flat file that you're building. Right, so if I queue a D here, it goes to the stack, queue a B, queue the number 2, right? We're sticking things on to the end of the stack, and then this third line of code says, hey, how many things are on the stack? Right, the queued will tell you how many things are on the stack. If you push things onto the stack, well, then you're going the other way, right? So if I push a DB2 onto the stack, I get 2BD because I'm pushing things to the top of the stack rather than to the bottom. And then, of course, I still have 3 things on the stack. Of course, the last way to do this is to mix and match. Right? I push a B, I queue a 2, I push a D. Yeah, I don't know why you would do that, but Rich says we can. Again, as a practical matter, I use queue quite a bit. Add something to the stack at the bottom, but you can push from the top or queue to the bottom, either way. Again, we're going to see this used in the DB2 interface when we start issuing DB2 commands. It's probably the easiest way to do that. Okay, when you pull things off the stack, here I queued my stuff up, and I'm pulling things off the stack now. And just saying. So say is it's a verb just kind of like display in COBOL, right? Just push it out to the terminal if you're in TSO. Okay. And the second example there, you see we're actually writing something out to a file. So disk write. My DDN would be a DD name, hopefully in the JCL if I'm in batch, or in my TSO session if I'm trying to do this in TSO. And I'm just dumping what's on the stack to that file. Okay. So let's take a look at the REXX DB2 interface, and how do I, we could say a lot more about REXX. In fact, we have a 3-day class on, what to do with REXX, how to do all of the, all of the programming and stuff I can do in REXX. But we're most interested here is in the DB2 interface. So I mentioned before, DB2 doesn't really have a native scripting language that we can use, directly with ISPF or TSO. A lot of us buy third-party utilities, or a lot of you buy third-party utilities. I work for a smallish company now that does not own any of the fancy DB2 utilities that that some of you own, so I end up writing a lot of things on my own. We home grow things. And if you're going to grow things on your own, you can use the tools that DB2 gives you, like DSN TEP2, TEP4 now, DSN TIAUL, unloads data. You can write things in COBOL or assembler or whatever your favorite mainframe development platform is. Or, REXX is a kind of an easy way to quickly develop things that you might use. So here is some pseudocode, I think. Right, if you're familiar with dynamic SQL and something like COBOL, then this will look familiar. Right, I'm going to prepare a statement, declare a cursor, open that cursor, keep fetching until I'm done, and then close the cursor. We mentioned before that in dynamic SQL I can't do a singleton select. So even if I'm only going after one row of data, I got to go through the steps of a cursor. All right, so I got to do an open, fetch, and close. And we can run prepared statements too in dynamic SQL. So in other words, if you're going to issue the same statement repeatedly with, say, different values for host variables, we can prepare it once and then open the cursor many times with different input. Okay. So before we can talk to DB2, we need to establish the environment. So these 2 lines of code in the first box there, I just have in the housekeeping section of my REXX that's going to talk to DB2. Address MVS, go find DSN REXX. So DSN REXX, every IBM program product has that 3-letter identifier that tells you what it is. For DB2, if you're going to invent a product called DB2 and then you need a 3-character identifier that identifies what this product called DB2 is to, in the IBM program product library, I might have picked DB2, but for whatever reason they picked DSN, right? And you've seen this in other program products like DFH is CICS, IGY is COBOL, right? So every IBM product has this 3-letter identifier. So DSN REXX is the DB2 REXX interface, so I have to make sure it's there. These two lines of code put it there, and if you're done, when you're done, you can remove the REXX interface at the end of your script. Okay. Again, we don't need to understand too much exactly what these things are doing, but they do have to be there. So in your housekeeping section, you need that there. Once the REXX interface is there or present in your environment, then you need to actually connect to a particular DB2 subsystem. So I can now say address DSN REXX, connect, and give it a subsystem name. Now, your REXX script does have to be running on the same LPAR, with the DB2 that you want to talk to. If you're data sharing, you can use group attach here, right? Let it attach to any of the members that are currently there on your the LPAR that you're running, or you can put a specific DB2 subsystem or member name in there. Because the connection can fail, When it does fail, I would like to know that and go off to an error routine here. So I do check SQL code after this. And if it's not 0, it means I'm not properly attached to DB2, and I'm going off to my error routine. You'll see the error routine in a little bit, and that / in REXX is a not, so SQL code not equal to 0. Go to my error routine. Probably more likely than hard coding, which subsystem I'm going to connect to, I'm going to send it in through a parm. There you see I'm just putting it in a variable. The second example there, DB2 SSID equals DB2A, and then I'm connecting to, that. It is pretty likely, though, that you'll send that in, as a parameter. So I think we'll see an example of, how you can, one way you can pull that in. We typically don't hard code which DB2 I'm connecting to because I may want to run this against, more than one place. Okay. All right. So here's an example of a simple SQL statement that we can run using the REXX interface. Okay. So address DSN REXX, right? That's the REXX environment, the REXX DB2 interface, and send it this SQL statement, exec SQL, update, test.myTable, set inquiry indicator equal to a yes, whatever all that means, right? And after that, I'm going to check SQL code. If SQL code's not 0, then something went wrong. Again, that SQL error routine that we're calling, we're going to see some of the code in there in a minute. But you see that I'm providing a couple of pieces of information to that routine, error note and error aid. Those are not DB2 specific things. Those are just things that my error routine expects, and it's going to end up displaying some of that out with the rest of the information. So in other words, if you have a REXX that has 26 SQL statements in it, in the message that we display out, it would be good to give it some idea of which statement failed or where in the script were you when it failed. Okay, so that's really what those two things are. They're just variables that the error routine is going to look at, and you can kind of work with within your own standards or guidelines in terms of what you do there. Okay, more on the error handling in a bit. Okay, so this is we might refer to this in dynamic SQL as an execute immediate. I'm just sending the statement in. I'm not preparing it. I'm just saying run this right now, and it's not very reusable this way. In other words, if I want to run this statement again, I'm going to have to build it again and send it off again. But it is a quick and easy way to run an update and then see if it worked. Select statements are quite a bit different than any other SQL statement that I might run, right? Including like DDL, like create table or drop table or whatever, which you can also do this way. A select statement is really one of the only statements that I can run that returns something other than a return code, right? So if I do an update, DB2 says, okay, it worked, or it didn't work. Go to the error routine. A select statement will tell you that, right? Yes, it worked, or no, it didn't. But then we also have to have some way to get the data back that it's returning. So select is quite a bit more complicated than anything else, almost anything else that I might do, the possible exception of calling a stored procedure. Okay. So here I'm trying to do a select, and you'll see one of the ways that I can kind of make use of what in COBOL we might call a host variable. We'll see maybe a better way to do it in just a second. So I'm selecting some things from, well, I'm actually parameterizing the name of the table here. So you see the double pipe there is a concatenation. So that's concatenating two strings together in REXX. And now this is the convention that I use that I got from Rich Fazio, that he probably got from somewhere else, but I think it's a really great convention to use when you're running longer SQL statements. So you see we're making use of what REXX calls there a stem variable. Okay. a stem variable is just kind of a multi-part string, right? So SQL statement .0 right there, SQL statement, the .0 of a stem variable just tells me how many of them are there. I'm saying this one has 3. And then you see I'm adding each of the 3 lines. So my statement has 3 lines in it. I'm going to create a stem variable that has 3 entries, and then I'm going to put the 3 entries in there. So if you write a SQL statement that has 20 lines, you would start it out by creating a stem variable with 20 entries and then populate them. This is just a sort of easy way to take a long multi-line SQL statement and make it sort of readable inside of a REXX exec. So if you kind of look at what's between the double quotes through all those, you're seeing an SQL statement, right? And I'm assembling it into this stem variable. Then this do x equal 1 to SQL statement .0, this is a boilerplate line of code then where I'm taking all of the entries in that stem variable and concatenating them together in a regular string or character variable called SQL statement also for use to send it off to DB2. Okay, so all I'm doing there is flipping through my stem variable, do x equal 1, 2, however many I got, and concatenating it all together. When I send a statement off to DB2, it just needs to be all plopped together in one big string. Right. So this is a way I can kind of build it in parts, line by line, but then put it back together. So this one line of boilerplate code is kind of piecing it back together to send it off to DB2. And then you see I'm doing address DSN REXX, exec SQL, sending that SQL statement off to DB2. Now this one is probably going to fail. In fact, I know it's going to fail. The reason this one is going to fail is that I'm trying to take a select statement and run it like that update that I did a minute ago, as an embedded statement, meaning, or as a singleton statement. I don't have any way here to get back what this statement is going to return. Right, so I'm selecting a bunch of things from a table where name equals whatever I'm sending in. And you see right here, I'm gluing the literal, what I'm calling a host variable there. So host underscore variable is kind of a REXX variable. And I'm concatenating in, a couple of literal single quotes around it and then just concatenating that string in. That is one way to do things. And, we'll see a different way in just a second. But this thing could return multiple rows. And as I've written it here, I don't really have a way to return anything back to the program. So this is going to fail, and this is not what I'm going to have to do for a select. But you can kind of see where, this is some animation kind of stepping you through what is getting built in this memory area, right? So I'm doing x equal 1 to SQL statement, so it's sticking that first line in, then it's concatenating in the second line, then it's concatenating in the third line. Again, we don't have, line feeds and lots of white space in here, but DB2 is not real picky about line feeds and white space. Us humans are when we try and read this thing. And there is an advantage to keeping this thing hanging around in the stem variable, and you'll see my error routine is actually going to make use of that. If the statement fails, my error routine is actually going to display it back out to me, the actual text of the statement that failed. And it's going to do it using that stem variable so that when it displays it, it's in kind of the same formatting that I used when I entered it. So it'll have 3 lines instead of 1.5. Okay, we'll see that in the error routine in a minute. That's actually very helpful, I think, when something fails, to see exactly the statement that failed, especially when you're building that statement using code, right? If you miss a single quote around a string or something, you're going to get a not so intuitive error from DB2, but if you can actually look at the statement that failed, the way it got built into that stem variable, you'll see exactly what happened. Okay. All right, so here's how we're really going to have to do this. And this is an actual REXX that I wrote not too long ago. Because I don't have tools, and because I teach a lot of DB2 classes on the Themis mainframe, and because we're very often needing to go look and see, hey, what columns do we have on that table? Right? What does my table look like? I finally got tired of going to Spoofy and writing SQL against the DB2 catalog every time I wanted to see just what does a table look like. So I wrote this little REXX, which just does that. Right? So you look at the query that I'm building there. So I got 5 lines in this query. You see SQL Statement.0 is 5, right? And I'm selecting some stuff from SIS columns where the table name is equal to something and the creator is equal to something, order by the column number. So column number in SIS columns, just 1 for the first column, 2 for the second one, and so on. Then you see my little on line 70 there, my boilerplate. All right, assemble this SQL statement into a not stem variable. And then I'm going to go out and prepare it. Now, those 2 question marks are, if you're familiar with dynamic SQL, they're parameter markers. So I don't know what these are going to be. I'm going to supply them later. All right. So when I go out to DB2 now, instead of just trying to run this statement, I'm going to say, let's prepare a statement called S1. We'll see a little bit more about what I can use there in a minute from what's in the host variable called SQL Statement. All right, so build my statement and then prepare it. A prepare is an executable DB2 thing, so it could fail. If I really am looking for a 0 there. If I get something other than a 0, I'm going to bail. Okay. If we scroll down, now I'm going to declare a cursor called C1. Again, if you're used to COBOL, you might think you could name the cursor whatever you want there. We'll see in a minute that REXX has some predefined cursor names that I have to use. Declare the cursor for S1. So take the statement that I just prepared and give it a cursor name. Again, I better get a 0 here. Anything other than a 0 is going to is bad news. Then down there, in the second statement, exec_SQL open C1, open the cursor using, and here's where I fill in the values of those parameter markers. So in my case, REXX variables called TBSN and TBCR, those were actually parameters that I passed in from how I invoked the REXX. Okay, so I'm filling in those parameter markers at the time I open the cursor. And that means this cursor is actually reusable, right? So I can open, fetch through it, close it. If I want to do it for a different table name, in the same execution, I can just open it again with different host variables. All right, the open cursor, just like the others, could fail, so I'm checking SQL code, go into the error routine if it doesn't. All right, and then I got to go into a loop. All right, do while my end of file switch is a no. I set it to a no at the very top line there. Fetch the cursor into a bunch of variables. If I get a 100, then I'm done. Otherwise, this is actually a little bit of an oddity in REXX. If your if-then condition is only one statement, then you just put the statement there, right? So if SQL code is 100, then set the EOF switch and do nothing else. If it is compiled of more than one statement, then you have to put a do around it. So there's a do and an end. There's an end down here off the bottom of the screen. So else, really you have to make that look like one statement, right? So you put a do and an end around it, around that block of code, right? So if I'm a 100, then I'm done. Now if I'm not a 0, if I'm not a 100 and then also not a 0, then I'm going to my error routine. And you see here I'm kind of building a, well, off the bottom of the screen, I'm building a string to display out of what's on that table. So we looked at statement names and cursor names there. Statement names are predefined. I got S1 through S100. You can't name statements whatever you want. You have to use one of those names. So you can have 100 of them going at once, which is probably too many. Cursor names And again, if you're used to COBOL, you're used to being able to name these things yourself, but you can't do that with the REXX DB2 interface. C1 through 100 are defined with return. That only matters if you're building a REXX stored procedure, which you can do. But 51 through 100 are also defined with hold. So if you remember what withhold means, that says, hey, if I do a commit, please leave this cursor open and positioned. By default, cursors get closed when you do a commit. All right, so we don't actually, define a cursor with hold in REXX. We just use a cursor 51 through 100 if we want that behavior. Okay, so you see I called mine C1. I'm usually going to use C1 unless I have a reason not to. The only reason I would have to use something other than C1 is I have more than one cursor. So then I would start with 2, 3, 4, 5. Or if I need withhold, then I got to start up in the higher numbers. Okay, but I can't call the cursors and statements anything I want. I have to use one of these predefined names. Again, a little bit unlike COBOL if you're used to that. And then you see what happens here. There's actually more in this REXX that I didn't show you. Before I go to the columns, I'm going out to SIS Tables and SIS Table Space and finding what table space this thing is in, what kind of table space it's in. So this one is in a classic segmented table space. You see the name of it there. And then the stuff under the word columns is what was filled in by the little chunk of code that we found or that we looked at. So you see it's an easy way for me to see what columns are on a table and what their data types are and what their null characteristics are. Without, most of you have tools that somebody bought you that will easily show you this, right? I haven't been able to convince anybody at my little sandbox shop to pay big money for those tools. So, when I want something like this, I have to build it myself. I give this to you as more of a sample of, if you have some application data even on one of your regular tables that you have a need to see quick and dirty like this, you can build a little script just like this. It took me, I think, probably 15 minutes to write this thing and then probably another hour to test it and work out the bugs. But it was fairly straightforward. You see the way I'm invoking it too with TSO. The script itself is called TB, right? Table, show me a table. And then the rest are parms, right? DB1A is the DB2 I'm connecting to. I'm sending that in. It'll connect to whichever one I tell it. Themis81.proj is the name of the table. There's a little bit of code too that I'm not showing you there where I parse that thing, look for the period, right, to determine which one's the creator, which one's the table name. Okay. But again, fairly simple and straightforward to do. Okay. If I want to call a command from REXX, what I'm going to do is use the DSN interface the same way you would do from TSO or from batch to run a command. So here I want to do a display utility. And what you see there is the display utility command being queued up onto the stack. I have to queue the word end, right? That's the DSN command interface, expects you to tell it when you're done. And we also queue a blank line onto the end of the stack when we're done. That's again just a convention that lets us know we're really done. Okay, and the command output there is going to be a stem variable that receives back what comes back from the output of that command. So really just a handful of lines of code here to run a DB2 command, and you'll see a REXX where we've kind of gone crazy with that in just a second. Okay, it's fairly easy to do. Error handling. So any of these statements that could fail, I'm going to want to check for that. So just like in really any procedural programming language, you want to check SQL code whenever you go off to DB2. In this case, I've decided that 0 is the only thing I'm going to tolerate, otherwise I'm going to my error routine. Right? So this particular one we said is probably going to get an error because I'm trying to run a select statement without doing all of that cursor work that we looked at a moment ago. Okay, and this is actually what comes out of my error routine. This is one way of doing this where I'm regurgitating the statement, right? So I have the statement in that stem variable. And so you see the first thing I do is display it, right? Just go back through that stem variable and spit it out, and so that I can see exactly which statement failed. These two things, right, my application diagnostics, these are those two variables that I just internally defined for myself as having error information. And what I put in there is usually just some marker from the program, so that I know which statement failed. You can think of this as like a line number. Probably not best to put a line number there because line numbers can change. But if you have 10 statements, put something distinct in there for each one so that you know which one failed. Right? Query failed might be a little bit unhelpful unless you only got the one statement in there. And you see I got a -104. Anybody been around DB2 a long time, -104 is kind of one of those not so very helpful SQL statements, right? And then I've taken the contents of SQL error M and just kind of spit it out in the diagnostics there. And that's usually where the real gold is in terms of figuring out what's really going on. Okay, so yeah, why did I get a -104 here? Well, because I tried to run a select statement without defining the cursor and everything. So here is the breakdown of what's going on in that error routine. This is one. So if you look at the samples that I've put out there, some of them do this, and some of them do something a little bit more complicated, which I'll talk to you about in just a second. This one is simply just flipping through the SQLCA and displaying out the pertinent information. So SQL code equals value of SQL code, SQL error M, and the various things and warning flags and all of that. Okay. That line at the top, that do x equal 1 to SQL statement.0, that's saying, hey, whatever I just put in that stem variable called SQL statement, let's flip through that and just say it. Say SQL statement.x right there in the middle. That is what is displaying the statement out so that I can see which statement failed. Okay. This you can pretty much cut and paste out of one of my samples if you want to have it in your own REXXs and just call it when needed. Here is, you'll see some of the other REXXs in the sample library do this instead. Instead of just displaying out the SQLCA, what we're doing here is building the linkage to DSN-TIAR. DSN-TIAR is the IBM supplied error handling routine that you probably call from COBOL and is also called from things like Spoofy. So if you get an error in Spoofy, you get that little 8 or 10 line, formatted thing about the error and all of the, the full message and all the tokens plugged in and everything. When we first went to try and call DSN-TIAR with REXX, Rich Fazio did most of the legwork on this, and I think he ended up finding on the internet somewhere someone who had made this work. When we asked IBM back in the day, and I'm not sure whether this has changed or not, we were told that this is not a supported thing, calling TIAR from REXX. So if you look in the samples, you'll see it done, and it works, but it's probably one of those things where every time you go to a new release of DB2, it could break, right? It's not something, it's a piece of code that we've made work, but may or may not be supported by IBM. But it gives you a much better message than just displaying the guts of the SQLCA with no context. All right, so again, I'm not going to talk through all of this. Probably the key piece there is after we're done assembling the linkage, right down here toward the bottom, we're linking to program DSN-TIAR. We're passing in the SQLCA that we built, the message and the length that's going to come back, and then we're displaying that out if you look down a little bit further. Again, you'll see examples of both error routines in the different scripts that make up the samples. So, again, use all of that stuff at your own risk, right? Asterisk, check with your DBAs before you, before you try and do any of this that they're going to end up being responsible for. Test everything more than once. We've also, Rich did a pretty good job of coming up with his own error messages too for, some of the application failures we might get. We built a little set of documentation for the tools that we came up with, and we styled it along the same lines as IBM does. What happens when you try and connect to the database and it fails? Well, Rich threw a message called RFM. I think that was Rich Fazio message, 0015. We didn't connect to the database. Okay, so we want good doc on whatever it is you're going to do. So just in the few minutes we have left here, I want to talk through a couple of samples, just things that I've used this for in practice. And again, I've kind of told you where REXX fits into my environment. And again, you probably, before you do this on a large scale anyway, you want to have a conversation about where REXX would fit in your mainframe shop. One of the things, and this is not something that most of you are going to run into, but because I work in a training environment, we have the same sets of user IDs being used, in subsequent weeks by different people. And one of the things we want to do in between is kind of clean up. So if you take my class this week and you create 10 files and then you go into DB2 and you create some tables and add some data, all because we're doing workshops together, that all makes sense. Just when you're done, I want to clean up ahead of the next person that's going to use that same ID. So I actually ran this I wrote this cleanup script that I run in batch, and you can see here one of the ways to run REXX in batch is to just invoke a TSO environment, right? IKJEFT1B in this case, or IKJEF. Just build a TSO environment and then invoke REXX via that TSO in your batch environment. So here I'm invoking a script called cleanup and I'm giving it an ID. And what this cleanup script does is it actually goes out and does a listcat on all that ID's files and issues deletes for them. It actually goes into DB2 as well and looks for all of the objects that person created and drops them and so on. So it's just a quick and dirty cleanup of an ID. I don't think I provided this one as a sample because I don't want anybody accidentally running it in their real world and then holding me responsible for what happens. Most of the time, you guys probably aren't going to be deleting everything for an ID. A little bit unique to the situation that I'm in. And this is what it does, right? Deletes any data sets owned by that ID, queries the DB2 catalog, and drops tables, views, and stored procedures created by that ID. All right, here is probably the my favorite thing that we've done with REXX over the years. This one, Rich Fazio put together, and then I've updated it a little bit over the years. Probably back in 2002 or 3, long time ago, but one that I still pretty much use every day, and that is what we call DispUtil. Now, if you look at the IBM display utility, you get 8 or 10 lines of output for every utility. You have important things mixed with unimportant things, right? It's just not a, it's thorough, but not a very clean way to look at a display utility. And if I've got 20 utilities running, I got to scroll through pages and pages of data in order to be able to see, the things that I like, right? Keep scrolling, keep scrolling. So this was our answer for that, and it's called DispU. Probably actually, if I go back a page here, one of the things that made Rich write this to begin with, or start writing it, was looking at a number like, well, let's look at this build count, right? This tells you how many, we're in the build phase of, looks like a reorg or load. How many index entries have we built there? It's hard to tell, right? No commas. So I think it was actually the commas that got him started. He was just going to reproduce this with commas, and then he got carried away and did something even better. So is that 326 million, or is that 3.2 billion? Kind of hard to tell. Gets to be a lot of rows that we're working with these days, right? So this was his answer. Number one, we put commas in the numbers. And actually there's a whole separate REXX in the kit called format number that he calls to do that. So you send it a big number and it decides where the commas go and sends it back. That's really all it does. And you also see that in my DB2 subsystem right now I have 4 utilities running. 2 of them are active, 2 of them are stopped. What phase they're in, and the counter with commas added. So that was indeed 3.2 billion in my index bill as opposed to 320 million or 32 billion or whatever you guys have in your largish tables now. So what I'm going to do here, and the way he's got this coded is if you hit enter, it's just going to run it again. You have to actually type quit to get out. So you can sit here for that 3.2 billion row index build and hit enter and watch the number go up. Hitting enter and watching the number go up does make the job run faster. I'm pretty convinced of that. My system programmer tells me otherwise, but I don't know, especially when you have that big a utility going on. I think most of us DBAs are going to sit there nervously and watch the number go up. So if you keep hitting enter on this, you can watch those numbers tick higher and higher until they're done. This is a nice little clean display utility, right? It takes all the essential information and puts it on one line. The non-essential information is discarded. If you really need all that information, you can go run the good old IBM display utility. All this thing is doing is queuing up a display utility to the stack, sending it off to DB2, and then parsing what comes back. Okay. He has it so that you can either run this in a terse mode or in a verbose mode. So this is the verbose, right, where it gives you more of the what are the sub tasks doing in the utility, again with commas, right? If you select one of them, so like you could select number 3, you're going to get the verbose by default if you're just looking at a single one of them. Right? That's probably my favorite thing that we've done with these samples. Real quick, another one that we did was what we call SQLProc. This is kind of like a batch SQL processor. It's a little bit like TEP2 or TEP4. The only difference is, well, the main difference is it can't run a select. We didn't try and figure that out. But what we added to it was the ability to tolerate an SQL code. Right, so right here, this stuff that looks like comments, -- SQL test -204 dropped already is okay. That is a comment, but the REXX is actually looking for SQL test and saying, all right, if you get a -204, just keep going. Right? In other words, that's expected or anticipated, and we're just going to display the message shown there and keep going. All right, so -204 on the drop index is okay. -803 on an insert we're saying is okay. Right, so it's like a TEP2 or TEP4 where it gives you the ability to tolerate specific SQL codes. Boy, I use that one quite a bit as well. Apple Checker, boy, I could talk about this one forever. This was a DBA kind of thing. Allowed me on an environment that had hundreds of tables to make sure that all of the tables followed my rules. So in other words, every table in this environment was supposed to have, the same creator. It was supposed to have 5 aliases. Some of them had an optional alias, right? All of the tables needed to have select authority granted to user 1 and update to user 2. And the views had to have a different security profile. So what Apple Checker did was, went out and looked at hundreds of tables in a database and just made sure that they all followed my rules and then reported on the outliers. In other words, hey, table 26 is missing one of the 5 required aliases and you didn't grant update access to U2. Okay. This one would need to be adjusted for your own shop, but it takes in a pretty complicated control card and tries to apply it to an environment. One more here, and then I think I'm probably done talking. Dropping a table space was another one that we found to be a little bit troubling, and then we went through a period with a particular application where we were dropping and recreating very large-ish tables way more frequently than we should have. When you drop a partition table space that, say, maybe has 1,000 partitions, that's 1,000 underlying VCM data sets that are going to be deleted when you commit that drop. And if you had a partitioned index on it, that's 1,000 more. So you're getting into a fairly long amount of time that it takes to actually drop something. And while that drop is running and committing, you're holding locks in the DB2 catalog and directory, and probably most importantly in the DBD, while it actually goes through and physically deletes all those data sets, which could take, well, in our environment, it took something like 10 to 15 minutes for that to finish, and you're hanging on to things that are kind of important to DB2 in that interim. So we wrote a REXX called tsDrop, and you sent in the name of the table space you wanted to drop, and then it went through these steps in order. It would actually issue a stop database or stop database and table space on the object and all of its indexes. It would actually go out with ID cams and delete each of the underlying data sets for the table spaces and indexes. All right, so while I'm doing all this ID cams work, it is not holding on to anything in DB2. So we're going ahead and cleaning up the underlying data sets first, and then at the very end it issues a drop table space. And with no data sets to delete, that drop runs very quickly, and we only hold on to the catalog directory and DBD locks for a very brief amount of time. Okay, so we're doing all the same things that DB2 is doing here. We're just doing them in reverse order, essentially. And by the time we get to the drop, then it's very quick. I actually just dusted this one off after not running it in a while the other day and tested it, and it still works great. And that is in the kit that you can download. Okay. Reference material, all this stuff is good. Again, all of this is based on an IDUG presentation that DB2 or that Rich Fazio did way back in 2005. You can still probably find that in the archives of the IDUG website. A lot of these books are old, but the good news is not a lot of this stuff has changed. Right? REXX is about the same as it was in the early aughts. So what's in the books is still pretty good. All right. This is the way to get a hold of me, dsimpson@themis-inc.com. Check out the website again, themis-inc.com/REXX for the samples, and themis-inc.com/webinars for the replay of this later today, and lots of other webinars that we got going on out there. So thanks for hanging out with me for an hour this morning, and look forward to hearing from some of you on how this is working out in your real world. Have a great rest of your day.